Digitizing existing plan and profile drawings in PLS-CADD is very easy. This video will describe the steps that are outlined in our tech note if you'd like to follow that along. Before we can begin digitizing plan and profiles, we must first have a plan and profile. So we need to scan that using a scanner. Here's an example plan and profile that's been scanned, looking at it in Paint Shop Pro. If we were to zoom in, we'd start seeing the plan and the profile portion of the scanned-in drawing. As you can see, it's a fairly old drawing, but we're going to digitize this inside of PLS-CADD. So we've digitized this, and we've got it ready to go. To do this, let's start PLS-CADD, and we'll do a File, New, PLS-CADD, and we'll choose a project, and I'll just call it Digitize.pfl. Okay. So now we'll need to attach the image that we just chose. So let's go to Drafting, Attachments, Attachment Manager. We'll choose Attach, and we will go into and find our image of our drawing that we scanned in. We'll open that up. We'll get a georeferencing. This is pretty typical and everything. If it's not a georeference project, you'll just click OK. That's all right. Since this is a plan and profile drawing, but we want to scan it in the profile view, let's attach it to the profile view. We'll get an option here that says OK to reset values, so drawings attached at the end of profile. You can choose yes or no, but it's easier with yes. And you'll see some default values in here. Just accept them. Click OK. And we can click OK out of the attachment manager. And we can see right now that we cannot find our profile view, but that's because we are in the plan view by default. Let's go open up a profile window by going to Window, New Window, Profile View. And of course now we see our images. We'll maximize that so we can see it better. Alright, now that we have our images attached, let's go in and start what I call rubber sheeting these images. All of that can be found underneath Drafting, Attachments, Calibrate Sheet. And a calibrate sheet is going to ask for a particular sheet to calibrate. Now, one thing to do here, as you'll see, we'll begin to calibrate. And you can notice in the lower left-hand, it's click on the left of station axis. It's kind of hard at this scale to click on the station axis, so we might need to zoom in as much as you need to do to get accurate with the points. As you notice, as you zoom in, sometimes pencil lines become 2 or 3 feet thick. So you need to use some judgment when you're doing this. The first station I clicked on was 2368. 2368, don't forget the 00 and the old station formatting of the +00. We'll click OK. Now it's going to, if you notice in the lower left, it says click on the right of the station axis. So I'm going to slide across. I'm going to hold my Shift button down and fly across the drawing. And we'll get to the side here shortly. And 2432, again, we'll use our best judgment in splitting the thickness of the pencil. And we'll do 2432.00. And now we'll want to know the click of the first 2 points with a known elevation. So I'm just going to slide down the drawing, and soon we'll find our elevation, 6380. 6380. And our last step in our calibrating our sheet is to find the fourth one. If you notice down on the bottom, it says click on one. And as soon as I let off, it'll say that. Click on the second and the 2 known points. And I'll type in 6280. Before I click OK here, as I'm doing the horizontal scaling, it's best if you pick a line that's continuously across the whole drawing. In the vertical scale, it's best if you pick a vertical line that's up and down above each other like I did. Makes it a lot easier. Click OK. It's going to ask if you want to rotate the drawing because the scan wasn't perfectly square, and we'll say yes. And it looks like nothing's going on. I'll click on the initial button. And now we'll see that the drawing has been recentered, and everything is ready to go now to start digitizing our drawing. Before we can start digitizing, it's a good idea to load up a feature code file. So I'm going to go to Terrain, Feature Code Data, Load an FEA file. This could be your standard one. It could be one off of the internet. I've got one in here ready to go called Digitize. And just so we can see that real quick, Feature Code Data Edit. There's our various voltages, and we can see all of the feature codes that we'll be using on this line. Now I'm ready to begin digitizing. Let's zoom in over here on the left-hand side of the drawing to get started. I'm going to zoom in the profile area. And I'm going to go Terrain, Edit, Add PFL Point. And the first thing that pops up is a dialog box on the left-hand side up here where we can choose the point. In this case, feature code 200 or a mass point, description, offset, angle, profile. If any of that we want to change, we'll do that shortly. But for our general profile, we'll leave it all blank, and we'll begin just by clicking right here in the beginning. First thing that pops up says attempt to add PI because there are no PIs in the project yet. That's fine. We'll say OK. And now we'll just start moving down the line. And as I start moving down the line, I'll just need to try to click a point every time there's a change. Now, as you notice, sometimes it's hard to see the center of the profile. Don't be afraid to go further than you needed to. So I'm just going to pick a point down here, and now we can quickly see that I did miss some points in here. So I can put my mouse on here and get more accurate each time I click. Again, we can click further than we need to. And then clean up the changes as we go back through there. Another way to do that is to go to Drafting, Text Size, Line Width, Style, and Color. And we can go down to our center or our ground line, and instead of black, I can change that and make it pink, for example. That might be easier to see. Now click OK. Our center profile line is now pink. It might be easier for you to do this as you're digitizing. Again, we can use a shift and fly down the line. Don't be afraid to go too far. Go back in and clean it up. Looking good. Okay, we get this one little stretch right here, and we notice that we have some side profiles. Let's finish the center one real quick first. So I'm going to kind of get that going through there. We'll come down to the bottom of our ditch. We'll come across through here. Sometimes it's nice to have the existing drawing next to you as you're doing this. Sometimes it's easier to see it on those drawings than it is on the screen here. Notice that we have a 20-foot left and a 20-foot right profile. Okay, in order to add those, all we need to do is change our offset. So I can come into offset and say minus 20. And that would be the 20-foot left, kind of figure out where it starts going off, start clicking here. See the blue dashed line, the side profile. You can see the clearance line up there above it that's following it. Again, if you go too far, you come back in and clean it up. Pull that in. And then the right profile, same way. We'll change that to a positive 20. And then I'll click on the divergence point right here. We'll come over and click there. You may need to fill that in a little bit. You should see shortly you'll be able to follow the right profile. And within that little bit of clicking there, we've done our center, left, and right profiles across the ditch. We can also go in here and change this, for example, to the conductor attachments. I don't want to do an offset, so I'll make that back on 0. I can start clicking on conductor attachments through there. This particular example has some transposition structures in the middle of it. So I'm going to go ahead and click on both transposition attachment points. And not only can we do conductor attachment points, but I'm also going to choose conductor elevation points or point of conductors. You don't have to be in midspan, but you can pick somewhere close to where they're going in. This would be advantageous later when we want to snap our conductor sags to fit what's on the drawing. So you kind of get the idea here, and within a few minutes we should be able to digitize this entire drawing. If we had any distribution crossings or roads or anything else that we needed to come in and model, we could do that. This drawing does not have anything like that, so we won't be doing that for this example. Now, real quick, I'm going to switch to a project where we've already digitized all the points here. It would take maybe another 5 minutes, but in the interest of time in this video, we'll go ahead and load those points. Okay, so now we have a project loaded with all of the points that have been digitized for the center line, left and right profiles, conductor attachment points, as well as a few midspan sags. An additional point that we didn't describe earlier was a PI. As you can see in the plan view of the scanned drawing, we had a PI, and that was simply done by just doing a terrain edit, add PFL, and you can indicate the angle as you click on the point. And you could, if you had a feature code for PI, I believe we have one in this file. Yeah, we could have picked a feature code 10, given it an angle, negative being a left-hand turn looking ahead on line, a positive being a right-hand turn. So this would have been a negative angle. Okay, it's already been added, so we don't need to do that. Now we're ready to start digitizing this line and adding structures. So let's just go to Structures, Add, and we'll just swag some structures in here close. It don't have to be perfect. I'm going to click on that one, and it says what structure we want to add. That would be a 408-4-60 standard structure indicated on the drawing. And we'll just continue to do that down the line. The next one would be the PI structure. That's a 405-2-60. And continue on down. 408-4-60. Tangent structure. Now we get into our transposition area. So we're going to have some transposition structures, 406-2-80. You can see the transposition format. And we'll just keep on going down the line. 406-2-75. Next one, 408-4-60. Another 408-2-60. And then finally, the last one, it's technically a tangent, but in the interest of what we're doing here, we're going to make that a dead end and make it fit so we can terminate our wire on this. And that would be a 412-2-60 foot structure. And so we've got all those structures in, and okay. And now let's swag some wire in. Let's do a section add. I'm going to begin on the dead end there at the angle. And we'll just start with the conductor. We'll skip our static wire for now, and we'll just do a next and scroll down through the line just like we'd be building it. Dead end, yes. And now it says what conductor do we want to string? I'll say Drake. And we'll need to fill out the conductor information, 115 kV. Let's not worry about the sagging information right now. We'll take care of that later. We'll leave it red. And we'll assume that when this drawing was drawn several years ago, that it was drawn at 120 degrees F, maximum sag, both creep and load being considered. And we'll click OK. And you can see that we have an underground transmission line here, so we still have some work to do. Two steps that we need to do is snap the structures and then snap the wire. I'll zoom in here so we can see this a little better. And we'll snap the structures first. Structures, move on. I'm going to snap the structure cable attachment point for a designated set and phase because I want to snap it to the points that I digitized as a cable attachment point. And we'll do set number 2, phase 2, that happen to be the middle phase of the transmission circuit. We'll snap the station and we'll snap the height to adjust the structures up and down. We're not going to worry about the offset because we want to keep the center of the structures on the center line. We'll do an OK, and now it's just a matter of clicking on each structure, dragging to the closest point that we want to snap it to. For example, if I grabbed up to this one, see how phase 2 went to the top one? That's not correct, so I'll drag it down to the next one. And we'll take care of that on the rest of the line. Most of the changes are very small. You notice they're less than a foot, and that's just due to error in the pencil thicknesses or even sometimes errors on the drawings themselves as they were drawn many years ago. All right, now we've got our structures done. Now we can do our wire. Let's do a sections graphical sag. And we can just go grab that wire and notice that the 120F maximum sag pops up, and we can just drag that. Notice how it drags up and down. We can get pretty close. It's kind of nice to see how the curves fit through there. Probably a better option is to go to options and say fit to a survey point closest to the mouse, and then we can just click on one of those digitized points, and you can kind of slide down the line and look at the rest of the curve. It's kind of nice to see how a curve today would match something that was drawn 40 years ago by hand. Once we get that fit, 120 degrees F, maximum sag, that's what the curve was originally drawn at. Click on Apply, close that out, and basically we have a line in PLS-CADD from an old plan and profile drawing. If you wanted to carry the project even further to make it even more accurate, there's a couple of further things that we could do. The first thing we could do, if we went to the Plan view, Window, Plan, we'll notice that our line is basically oriented in 0, 0 with the first segment heading due north. That's just by default. We could easily orient this so that it would be correct with our state plane or other local coordinate system. And that's, you can go to Terrain, Edit, Edit Origin. And so we could say that the azimuth, for example, in this project, I looked at the azimuth of the first segment. The azimuth of that was 67.6083 degrees. The state plane coordinate of this particular project, the very first PI, was at 1956747.37, and the easting would be 1693327.158. And when we click OK, project disappears, we initialize that, and now we're back on a project. So a project is now oriented correct with the local coordinate system. And to further illustrate how that could work, if we were to go back into Paint Shop Pro and take our particular project, we could crop it, the plan out of it. I could just do something like this, image crop, and then we could save this as a plan perspective of our particular project so that we could pull this in and use that in our project. For example, go back into PLS-CADD, we'll go to Drafting, Attachments, Attachment Manager, and I'm going to attach the plan perspective that we just saved out. Again, the geotip, we'll click OK. It's going to come up with some default numbers. These numbers may or may not be correct depending on how you digitize or how you save them out of Paint Shop Pro. I do need to make some minor changes here. 833.87, 178.3784.27. Again, just looking at the coordinates of the plan perspective, put that back on 0. Our width is 6648, 2120, and we do need to rotate this image 52.25 degrees. Let me double check those numbers. 4833. Good thing I did. I had a mistake right there. 217, 1783784. And when we click OK, we now see the plan perspective of that drawing is now part of our project. So now we have an old plan view that's been included in our project. If you would like to finalize your full plan and profile drawings inside of PLS-CADD, that can easily be done. Let's finish that out. Let's go to Window, Plan and Profile Sheets, and you can see the default plan and profiles from PLS-CADD. Obviously, this is not what we want. We can finalize this by following the steps that are outlined in another tech note that we have regarding making plan and profile drawings. You can look that up on our website. But to do that, let's go to Drafting, Load PPS, and we have a standard settings for a particular project or utility standard, whatever. Open that up. Looks like it kind of messes up. Let's do a repage and then an initial so we can see the entire page. And then we can finish this out by simply going to Attachments, Attachment Manager. And let's attach our border. So we're going to attach the border and open that up. And we'll attach that to the plan and profile view in inches. No, we don't want to transform it. We'll click OK. And now you can see the border of our plan and profile drawing. And we also have a logo that we'd like to attach. An easy way to do that is just merge it from another project. We can go to Standard Done, and you can see our logo down here in our border. And then finally, just our standard text. So we can go to Drafting, Lines and Annotation, merge from another project, and we have a standard project with all of our standard text. And we'll see down here as we zoom in, that we'll have all of our standard text for our project. Okay, so you can quickly see how we can do that. If you want to leave the profile sheet attached, you can do that. You may find it helpful once you emulate all this information in PLS-CADD to just go to Drafting, Attachments, Attachment Manager, and go to the original profile and just hide it. And when you hide it, then you'll see that you have just a profile from PLS-CADD with any of the information, including structure information that you may have had, as well as the plan view of our drawing. And you can finally print this out and have a complete intelligent plan and profile in PLS-CADD as opposed to the old drawing that you had in just your manual format. Hopefully that should take care of it. Again, there's a tech note that covers all of this stuff in detail, as well as a tech note on making the final plan and profile drawing. A PDF of this particular plan and profile drawing will be available to download from the tech note as well. The same process could be used for all of the rest of the drawings by simply just attaching them, calibrating, and digitizing drawings. When you calibrate them, the ends will match up with the beginnings of the previous drawings. So they'll just be one continuous drawing. Sometimes you may want to attach all the drawings and then digitize them all, or you may want to attach a drawing and digitize each one at a time. Whatever is your preference, and it will both work very quickly. Usually approximately 30 minutes or less per drawing is a safe number to assume. Thank you, and we hope that you really enjoy digitizing with PLS-CADD. Thank you, and we hope that you really enjoy digitizing with PLS-CADD.